So today's lesson, we're going to take a look at counting problems when we deal with multiple combinations. And this is a very specific outcome or a specific counting problem, but we're going to be able to apply some of the thinking that we've done over the last few lessons into this. So before we talk about this rule, we're going to talk about how this rule comes into being. So we're going to take a look at, you have an apple, an orange, and a banana in your fruit basket. How many ways can you choose some of the fruit? So there's a few key words into this. Some and choose. So when you hear the word choose, all right, that's going to ring to your mouth a combination. All right, so we're thinking about it as a group, that type of thing. So you can think about this as how many ways of choosing some of the fruit. So if you think about it, there are 4 different ways of doing this. I can choose 1 fruit, or 2 fruit, or 3 fruit, or 0 fruit. Okay, so that's kind of the baseline. So if I was looking at this, we know we have 3 different kinds. All right, so we know that if we choose one of them, it's going to be an apple, orange, or banana. Well, there's going to be 3 ways of choosing that. Or another way of saying that is 3 choose 1, which is still 3. Or I could choose 2 fruit. Well, you could do an apple and an orange or a banana and an apple. Likewise, that is 3. Or 3 choose 2. Or you could choose all 3. Well, that's an O, an A, and a B, or 3 choose 3, which is 1. Now, you look at this, well, 3 choose 0, there's actually one way of doing it, and that's not choosing any of it. So those are all the outcomes. And one of the things that we're going to look at is that this is not a desired outcome. The reason is the idea of choosing some. In this here, I'm choosing no fruit. So that means we don't want this option. And then I can look at those other options, all right, as 3 plus 3 plus 1. Well, that is 7. So the answer for this question is 7. Now, it seems very trivial that you could do it like this. But what happens when you have larger quantities of items? Well, if you look at this, originally there was actually 8 options. And this is where this formula is going to come into play, 2 to the power n minus 1. Well, if I look at this, 8 is actually the same way of saying is 2 to the power of 3. Well, 3 is the number of original options. I'll write it down here. Number of original objects. And the 2 part is the idea of choosing or not choosing a single item. The idea there, it's a yes or no thing. So I could choose an apple and orange, or I could choose an apple or not choose it, choose an orange or not choose it, choose a banana or not choose it. And it's kind of like saying 2 times 2 times 2. But the problem with this is, in here, there's one way of not choosing something. So what we have to do is subtract that opposite, that one option that always is the case of not choosing any. So in this case, that is another way of getting that answer. So this is how we can deal with larger quantities, is where we have n distinct items and we choose at least one of them, and then 2 to the power n minus 1 is the answer. So it's a very simplistic rule and it's very limited, but the idea there is this is another way of organizing it. Could you have done that this way? Absolutely. But this tends to be more concise at the end. So we're using the idea of our combinations and seeing another pattern. If you have ever seen Pascal's triangle, and I'm going to write it up here. If I was looking at the third row, all right, 1, 3, 3, 1 is that third row. The sum of that third row is 2 to the power 3, which is 8. So that's kind of where this idea came from. It's applied from Pascal's triangle. All right, don't really need to remember that, but this is applying it to those options. So just to recap from this question, if I have distinct items and I'm choosing some of the fruit, so it doesn't tell us the group size. That's the key. All right, I have to choose something. Okay. If I'm looking at the second question, how many different groups can be created for 20 people to study the effect of cell phones in the school? So if I'm looking at this, here's my thinking. All right, I'm choosing groups. But we're choosing basically at least one item. In this case, it's person. All right? So that means I can use this. So as long as I know how many people I started with, well, here my n is 20. So I can use my answer and I can do that with my calculator. So I can go to my calculator, 2 to the power 20 minus 1, and I can get my answer from that, 104,875. So this would be the number of possible groups created from 20 people to study the effect of cell phone usage. Okay, so this is the thinking. Choosing at least one item or person, and in this case, they're all distinct. That's the key part, because people are distinct, right? You can only have one of each. Okay. Well, I guess I should put the answer here. 104,875. Okay. So choosing groups has to be the first thing, so you're not arranging items. Arranging items is a different thing, and we've talked about that already in a previous lesson. And we're choosing at least one, so we don't have a definite group size that we're choosing. All right, and at any time if you need to push pause to write down stuff or rewind, please do so. All right. So I have another option. So we're going to look at combination of items with some items are alike. So total combinations of choosing at least one item is this formula. Okay, so we're not asking you to remember that formula, we're asking you to apply this formula. So the idea here is I could have, so let's say if, and we're going to talk about this, the idea here is you have A items plus the 1 of choosing of item 1, so on and so on. Okay, and we're going to talk about what that looks like from question 3. So we have 3 loonies, 4 quarters, and 7 dimes. How many sums can be created using these things? So if we look at this, you have to ask yourself, are we choosing? Or we want groups here? So that's the first thing we want to think about. The answer is yes, because here the order does not matter. Right? We don't care how we add up. Okay? The second thing is we want are we choosing at least one item here? Well, it doesn't tell us how many coins we have to use, so the answer here is yes. And then 3 is, do we have some that are alike? And the answer here is yes as well. So that's where we use this. So the question is, why does that look like that? Or why does it work? So if I have 3 loonies, 4 quarters, and 7 dimes, what does that look like? Well, just like in the previous question, you had one way of choosing it and one way of not choosing it. This is the difference. If I was looking at the loonies, okay, I have 3 ways of choosing the loonies. I could choose 1 loonie, 2 loonies, or 3 loonies, or not choosing a loonie. And that's where that 1 comes in. This one is not choosing. So that has to be in there. Likewise, for the quarters, you probably guess that this would have to be 4 plus 1. There's 4 quarters, so I could choose 1 quarter, 2 quarters, 3 quarters, or 4 quarters, or not choosing a quarter. And the same thing works for the dimes. There's 7 dimes plus 1 of not choosing it. And in the end, we have to subtract 1 because there is one option where you've chosen nothing. So we call that the null set, but that's not a big deal right now. That's why we have to subtract 1, because there's an option here where we chose no loonies, no quarters, and no dimes. That doesn't give us a sum. So that's why we have to subtract 1 in the end, and that's why that works. If there was another option that you had, say if you had 15 toonies, you keep adding on to that formula. All right, the math is easy. The understanding of how to get to the math it can be challenging. So the idea there is just 4 times 5 times 8 minus 1. All right, 4 times 5. All right, so I have 160 minus the 1 option. Therefore, I have 159 different sums can be created. And then I can do that. So this is important to tell me how many options do I have of each, and then I can fill this in. but the thinking to get to there is important. Are you choosing groups? Yes. Are you choosing at least one nominee? Yes, because we didn't tell us a specific scenario. And is there some alike? So this some alike is the only thing that's different from the first scenario. So that's basically the idea of that. All right. All right. Miss Martin likes to have some donuts. All right. She's got 3 apple, 4 vanilla, and 6 chocolate chip or chocolate dip donuts. How many ways at least buying 1 donut? All right. What I'm going to do is I want you to push pause, see if you can set it up, and then come back and see what that looks like when you finish pushing pause. So hopefully what you've done is you recognize that there was 3 apples, 4 vanillas. So hopefully you recognize that there was 3 apples, 4 vanillas, and 6 chocolate. I have to add 1 to each scenario because you have an option of not choosing one of those. So maybe you just don't like the apples. So I could choose vanilla and chocolate. That's where that 1 plus 1 comes from. And then we subtract off because there's one option that contains no donuts, and we don't want to count that one because it doesn't make sense. So that's why we subtract by 1, and then I can do the mathematics behind that. All right, 4, 5, 7 minus 1. So that is kind of the gist of the lesson. And if I look down here, all right, I can determine when to use this. This is the important part, is when do we want to use this counting technique? All right, so the counting technique is not hard. It's identifying when it's important. And I can determine when to use these counting principles compared to when we use the other. This is the key part. And when we get to summarizing all these things, it's identifying which option matches the description of the question. So give those practice questions a go and check your understanding, and we will talk soon.